So if you took the Junior Maths Challenge in 2020 this year, or perhaps you're looking back at the scores from 2020, you might be wondering, why were the grade boundaries quite so different this year compared to different years? If you look at the boundaries on the screen here, you can see that it's like a 30-point difference between this year's boundaries and last year's, and at least a 20 to 25-point difference between this year's boundaries and the averages for previous years. So for a bit of context, the Junior Maths Challenge in 2020 was totally different to any of the previous years because we have the lockdown happening at the moment due to the outbreak of the coronavirus. So usually this challenge will be sat in schools, but this year it's been sat by students online. And I think there are three key differences that have affected the scoring. Okay, firstly, it's just hard to administer and assess things online, and so it's very hard to know whether students have taken the test entirely by themselves. Maybe they've used a book a little bit, maybe they've got a bit of help from someone. But I actually personally don't think that's the biggest factor here. Another factor that really clearly has contributed is the fact that this year there were no penalties for getting questions wrong. So usually when you do questions 16 to 20, you lose a mark if you get it wrong, and 21 to 25, you lose 2 marks if you get it wrong. But this year that wasn't applied. But I think the third reason is perhaps the most interesting one, and we can even learn a bit of statistics as we do it, because I think that the total number of students taking this test must have gone down, and that there's been some self-selection in terms of the number of students who are taking the test and exactly who they are. So in this video I'm going to just go into a little bit more detail on each of those factors and explain to you why I think we can pretty confidently deduce the number of students taking the exam has gone down this year. Now, I want to say nothing at all in criticism of the UKMT here. I think they've done a fantastic job in getting the Maths Challenge up and running this year and giving students the chance to do it. But for those of you who maybe have taken the test and haven't done quite as well as you thought, I think this might actually partly explain that. And, you know, if you got a bronze where you thought you got a silver, I've got a bit of an explanation as to why I think that might have happened. So the first thing I mentioned was this idea that online assessment is difficult, and I think it's a bit too easy in a way just to say that because students took it online, perhaps they cheated. And of course there will be one or two students maybe who haven't done this supervised properly and perhaps have looked questions up or got help from someone, a little bit of help from someone as they're doing the test. But on the other hand, the Junior Maths Challenge is really a fun test, and so I don't think there's any great incentive for students to do that. And the students that I know that have taken this have taken it in good faith and have just got on with it and had a go at it as a fun test. So I don't really think that's a huge factor. Another possibility, of course, is that the 2020 paper was somehow just a lot easier than other papers. But again, I've looked at the paper, I've done it myself, and I don't really think it was very much different to previous papers. So I can't see a huge discrepancy there at all. So now let's look at the question of the marks not being deducted for wrong answers and think about roughly how many marks on average that should have changed the grade boundaries by, right? So usually you get 5 points for a correct answer to question 1 to 15, and there's no penalty for guessing. And that's exactly the same this year. So no difference for those questions. But for questions 16 to 20, you'd usually get 6 marks for each correct answer, and you'd lose a mark if you got a question wrong. Okay, so on average for those questions, how many marks do we think students have gained? Well, actually, usually it kind of makes sense to guess these questions on average, right? You lose 1 mark if you get it wrong, and you've got a 1 in 5 chance of getting 6 marks. So actually, in some ways, there's an argument for getting it right anyway. And the fact that you don't lose a mark if you get it wrong this year doesn't really affect any questions where people knew the answer and they got it right. So what it just allows people to do is to make an extra guess at maybe 2 or 3 or 4 or maybe all 5 questions that they didn't know how to do, and to get that for free. So I think there's probably a benefit on average of a few marks there. But we can't say for sure because it depends how many students knew the correct answers to different questions. So for questions 21 to 25, you lose 2 marks if you get it wrong, and you gain 6 marks if you get a question right. So actually the incentive for just guessing isn't so good here, although a lot of students still do, but you shouldn't really just guess because the odds are against you, if you like. So let's say you didn't know how to do any of questions 21 to 25, you would just get now an extra 5 chances, 1 in 5 chance of getting 6 marks 5 times. So on average, you're going to get 1 question right. On average, people might gain up to about 6 marks here. A bit less if we think that people do know how to answer some of those questions. So at most, I think the difference here, we're looking at maybe 3 or 4 marks on average at most for questions 16 to 20, and certainly, probably at most 5 or 6 marks on average for 21 to 25. So it could have pushed the boundaries up by maybe 10 marks, but certainly nothing like the 20 to 30 mark increase that we've seen. So the last factor, and the most interesting one in a way, is this idea of self-selection. What I mean by that is, let's say 50% of the students who usually took the maths challenge took it. Were they just at random? Or perhaps it was the case that of the students who took the maths challenge, it was the ones who were really keen, the ones who wanted to take the challenge, the ones who'd done some preparation for it, that really went out of their way to make sure they entered into the challenge. And so perhaps the system has somehow been a little bit unfair here, because they've kept the grade boundaries the same in terms of ratios. They've said 40% of people are going to get a certificate, and it's in the ratio of 1 to 2 to 3, gold to silver to bronze, and they announced that before they saw the results of the test. So it wasn't on an objective basis of we thought these questions were hard, it was purely a numbers game allocating the test. And I'm going to go in a little bit more detail on the whiteboard about this to show you what impacts that might have had on students. So let's say we usually have 300,000 students taking the maths challenge, and in ordinary times 40% of those get certificates of some sort. So that's 120,000 students. Okay, so now amongst those 120,000 students, the gold to silver to bronze ratio is 1 to 2 to 3. Okay, so there's 6 parts to this ratio, so that means there's 1/6 that get gold, 2/6 silver, and 3/6 bronze. So that corresponds to 20,000, 40,000, and 60,000 students getting gold, silver, and bronze. So suppose what happens this year was that actually the total number of students, rather than being 300,000, was 150,000, and that this rule was still applied. So now we've only got 60,000 certificates available, and still in the ratio of 1 to 2 to 3. So there's going to be a sliver here of 1/6 of 60,000, or 10,000 getting gold. There's going to be 20,000 getting silver, and 30,000 getting bronze. Now, if it's the case that just half of these students took the maths challenge, then all will be fine. But I think what might have happened is this. Actually, students who get gold certificates are much more likely to have taken the online version of the maths challenge because they're keen students, they might have done some more preparation. And so perhaps, let's just say, I don't know what the numbers are, but let's say 80% of the people who would usually get gold took the maths challenge. That would mean 80% of 20,000 is 16,000. Okay, so those students would take up all of these 10,000 gold certificates, and then 6,000 of them would get silver instead of gold. But then this is going to have a knock-on impact on the people who usually get silver. So let's say they're just slightly less enthusiastic, right? And actually they have a 70% participation rate this year. So that means that actually 28,000 of those students would be taking the maths challenge. But look, there's only 14,000 silver certificates left for them. So 14,000 of them will get the silver they deserve, and then another 14,000 will be into the bronze area. And again, let's say the bronze students are just slightly more likely than average, perhaps 60% chance of taking the maths challenge compared to the 50% of students overall that have taken it, and that would mean there would be 36,000 of these guys, but there's only now 16,000 certificates left for them, and so that means there's 20,000 students here who would usually have got a bronze and don't get a certificate at all. So this is actually a bit of a lesson in statistics as well, that when we reduce the numbers of people taking the challenge here, if it's at random, then yes, it doesn't make any difference to the fairness. But actually, if the students that we're selecting are somehow to take the maths challenge, actually they're self-selecting here, are the ones that were more likely to do better, we've ended up getting 6,000 students here who perhaps get a silver when they should have got a gold, and 14,000 who get a bronze when they should have got a silver, and 20,000 who don't get any certificate at all when they should have got a bronze. Okay, so I hope this video has been interesting and from the statistical side, and also if you've taken the maths challenge this year and you haven't done quite as well as you've expected, perhaps this is of some reassurance to you. But again, I would really like to say that overall, the main thing for the maths challenges is that you're enjoying the problems, and it's brilliant that the UKMT have been able to put this on even when the coronavirus is happening, and so many people have had a chance to take this contest. So perhaps it will be forever remembered as one that was very difficult, and certainly those grade boundaries are going to look like outliers for a long time, assuming next year we go back to the usual format. For those of you that haven't seen my channel before, my name's Kevin and I make videos on the Mathsaurus channel. There's loads of free content for GCSE and A-level maths. Head over to the Mathsaurus website or have a look at the playlists on YouTube. Please do like the video and subscribe to the channel. It really helps get a bit of attention to it and to get this message out there. So if you've enjoyed this video, or you know anyone who's taken the maths challenge and might be interested in this year, please do send this on to them, and let me know in the comments if you've got any thoughts, or if you've got any other possible reasons you think the grade boundaries might have been so different. Particularly interested if you took the challenge this year, or if you had a student taking it and they reported back that it was harder or easier than usual or something, or if they got the certificates they were expecting or not. So we'll leave it there for this video. As I say, please do comment below or like or subscribe to the channel, and I will see you in the next video.